Episode 13 of TylerMakes making a game in Corona SDK. If you have been following along, you'll notice that the last episode, sorry, just checking the audio, as I always do. If you've been following along, you know that the last episode, we did not finish our A-star algorithm, unfortunately. That is our goal today. And you might also notice that I'm streaming at a different time. This is usually when I stream a video game that I'm playing, but today we're actually going to continue working on building this because tomorrow everybody's going to be busy for Christmas, so I won't be streaming. So instead we're going to finish this today, and then tomorrow we're going to skip it. So anyway, my goal is to get this done today, so we're just going to jump in and keep going until we get it done. I'll probably go at least 2 hours, maybe 3, depending on, you know, what we get done and where I want to go next. So let's check it out. So where we left off was that we get this nice error when we run our code. We go and we hit play, we click a location, and we have an error on line 39, which if you look here, attempt to compare a number with nil. So we go here, 39, and what I realized was that our cost so far, our next neighbor is an object. And the problem is that objects can't be used as keys for tables in Lua. As far as I know, I believe that they won't work. So I just want to double check that. So you can do like nil. Any value. Short syntax form. See, I'm not entirely sure. Okay, there's also short strings. Tables as arrays, blah, 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 blah. Tables as references. Sorry, I have a cat that is very eager to watch this stream. Okay, so what I want to do is just test that, just to verify my suspicion. Okay, so we create our builder map. Let's try this. First, let's make sure that we're going to run this. Okay, good. That's gonna, I just want to verify that we're gonna run right here. Okay, so let's try this. Test table. Oop. And here we go. So we're going to try using an object. I'm using too many different languages. Okay, so object 1. And let's make 3 for good measure. And then let's go. Oop, a little too many. Okay, so what we're going to try here is we're going to try using those objects as keys and see if they work. I just wanted to tweet real quick as well. Sorry, gotta, send things out on the social channels. Make sure everybody knows that I'm streaming. If you're watching this on YouTube, like, subscribe, etc. That helps broaden the reach so that more people see it, and more people get help, and more people like it, and I keep going and doing it more often, etc., etc., etc. Okay, so let's see if that works. Oh, so it does work. Okay, so that's interesting. So I guess we can use objects as our hashes. So let's go find out why this is not working. Okay, I'm gonna save that. Okay, so A star 39 is not equal nil. Well, let's try to find out what is nil. The only thing we have here that we're not looking at is this. Yeah, maybe we haven't instantiated cost so far. No, because we're putting something in it right here. Well, let's find out. And we're going to play. So it's always good to test assumptions, just as a note. I had assumed that we couldn't use hashes for our keys in our array, but turns out we can. So, just a word to the wise, test your assumptions. So what I want to know is, okay, so we're still comparing a number to nil. And if we look at our values, next neighbor, 9, 8, cost is 1. Cost so far is nil, so this is coming back as nil. That's what we expect, that's fine. But now let's see what happens when we say does not equal nil. That should come back with true. Oh, that's what it is. Okay. This should not be an or, it should be an and. So the idea is that the reason you do this is if it's nil. Oh, wait. Huh. No, this should be an or. That's what we want. The idea is that if it is nil, this should return true, and then it should not check this. That's what a lot of languages do. Maybe Lua doesn't, which I did not realize. But let's find out. And we have a syntax problem. Okay, let's try it out. No, still 39. A star 39. This is false. Does not equal. Oh. Does not equal nil. If the cost so far does not equal nil, I think this should be equals nil. Let's double check what the heck we're doing. Remember, we're following this Red Blob Games tutorial on figuring out A-star. We're trying to make an A-star algorithm. Probably should have started with that to remind people and let people know if they have not been following along with us. But anyway, we are calculating A-star, and we're just implementing a priority queue so that we can implement spaces that have different weights to them. Now what I'm looking at is that if it's not in cost so far, or it's less. So if it's not in cost so far, that means this would equal nil. That's what it should be. So let's try that out and see if that worked. Okay, something's happening. It looks like we might have an infinite loop, or it just might be taking a long time. Let's, can we kill it? There we go. We're gonna have to kill Corona. Unfortunately, that does not, that's so annoying. Well, not the first time we made an infinite loop. Current does not equal nil. We would have to set current equal to the popped value. That's probably what it is. Let's cross our fingers and hope that's it, and that we don't run into any more crashes, because crashes are no fun. Play. Oh, something failed. That's okay though. At least it didn't go into crazy extreme. Okay. 119 in Bulbasaur Forest. Arithmetic on field I, a nil value. Where did our forest go? What's in here? Oh yeah, that's just 119. A nil value. Get neighbors. So we're getting neighbors on a nil value. I wonder. So we went through a few of these, and what we do is we get neighbors of current. Let's try this. And see what we're looking at. Okay. Yep. Okay, so our current is working at first, then we go through our neighbors, and then it immediately fails. Okay, so why does it immediately fail? Could be an issue with our pop function. Alright, so let's go take a look at our priority queue. Maybe our priority queue is not perfect. We will have to find out. Pop. Okay, so I'm trying to get the lowest P and Q. Ah, that's right. We need the value of the top, not the whole object, because the whole object has a priority. We just want its value. Okay, so now let's click. Ooh, that's a lot of printing. Cross your fingers that it finishes. I'm trying to see the values that are coming across here. My hope is that it's just running into an issue. Now, it looks like it's putting stuff on that it shouldn't. Because if you look, it looks like it's sticking to the same several values. Okay, that's gonna crash. So let's quit that guy. Find out what the deal is here. Okay, so let's just check over it once more to see if there's any obvious errors, and then we're gonna put in some more debugging to fix figure out what went wrong. Okay, so for each in its next neighbors, we've tried our neighbors function. That should be working fine. The new cost is cost so far plus get cost. Okay. So far, its next neighbor. Whereas new cost is less than cost so far. Next neighbor equals new cost. And then we put something in. Priority, insert. Okay, so what we're going to do is what we've done before, which is to make an easy out. Which is, this is going to keep us from having too many iterations and having it crash. This will save us from that. And that way we can take a look at what's happening and then fix it. Okay, so iteration 0 is, and iterations is less than 100. Iterations plus 1. Okay, great. So that'll keep it from exploding. Now, we're already seeing our current and getting our next neighbors. So let's take a look at that and see what is happening. If cost next neighbor or new cost is less than cost of next neighbor. Oh, we're already showing new and cost so far. That'll be helpful enough to let us know what's going on, I think. Okay, so let's try it out. Okay, so it should just go through 100 of these and then stop. And then could not path the location. Great, that's what we wanted. So now let's go take a look at this, analyze it to see what went wrong. Okay, so we start at 10.8, which is where our player is. Get our next neighbors. 9.8, 11.8, 10.7, 10.9. Okay, that all looks good. Cost so far for any of those is nil. That's correct. Okay, so now it was nil for all of them. So we're going to set a cost and then put those neighbors. So all of those neighbors should be put on there, onto our frontier. And we've marked where they came from. That's great. Let's make sure that's right. Insert indicate from next neighbor, location. Okay, yeah, that should be right. Okay, now we're gonna pop it, and that should be the first element. So 9.8, great, 9.8. Okay, so we're gonna go and add all the rest around it. Now 10.8 should not be in there. So why is it in there? Okay, so 10.8, its new cost is 2. Ah, here we go. Cost so far is nil. That's not right. So cost so far of the start is 0. So why, when we do cost so far of that, is it not returning 0? It's returning nil. Okay, I'm going to make this one iteration so that we stop immediately, because I want to see this. Here we go. We're going to do this. I want to see what is in start. Oop. So we know what the difference is between start and what our neighbor looks like. My pairs get neighbors. Sell frontier pop v. Interesting, because I'm looking at this and this pop v. So this first one should be our ij. I want to know why that doesn't work. So we're going to get the pairs and start. See what that looks like. And let's make sure that this is working. Okay, and now I want to do the same for one of the neighbors to make sure. Now we've put that frontier. Okay, yeah. So let's do this. So first, let's move current. Well, we'll leave current there, but we're gonna do this because if cost so far of start should be the same as cost so far of current. If it's not, then it means that this start, which was what we put on our frontier and what should be popped here, is not the same as what gets popped, which is a possibility. So let's take a look at that first before we go looking into the neighbors to find out what's wrong with them. Okay. Oop, let's go all the way down here. Okay. So cost. Wait, where is our cost so far start and current is 0? That's right. Trying to go to. That's interesting. Why did this pairs not show us anything? Is start potentially nil? That would be interesting. That wouldn't be right at all. We're hoping to see that it prints a table there. And that will tell us that, now see it's a table. Now why is it, let's try pairs. Maybe I did that wrong. Like I said before, I get confused between pairs and I pairs. Start pairs, there we go. I and J, great, 10. Now the question is, why does this one get cost so far nil? So what is it trying to do a cost so far of? Cost so far, next neighbor. What, pray tell, happened? Okay, so let's see. So let's see what our new cost is. Oh, this is interesting. Cost so far of current. This should return 0. Yeah. Get cost. Okay. So our new cost should be that. Now we're going to double check that this hasn't been broken. And we already know what next neighbor is, so let's do this. see if that is still correct. Okay, let's take a look. Okay, interesting. Very interesting. Okay, so next neighbor would be ideal if I could look at both of these at once. Okay, so what's happening? We've got our current, it's 10.8. We go through here. Next neighbor is 9.8. Its new cost is 1, that's great. Cost so far is nil. So at this point, 9.8, no, new cost, we were printing that there. That's great. New cost so far is nil. Okay, now testing. Its new cost is 1 and the cost of the old one is 0. That's great. And new cost for 9.8 is 1. Yep, and that works. That's great. We do that for all of them. The new cost being 1. Okay, so now we hit the next one, current 9.8. Cost so far is still nil in that case. But that doesn't make any sense because this neighbor is 10.8. 10.8 is what we started with. Oh, that's what we want to do. So we want to see if our neighbors have more pairs or anything than okay, we're gonna try getting rid of this. Paste. Okay, now we're going to find out if our neighbor pairs are different, because that would mean that the hash is different and therefore it's not going to get the same value. So, neighbor pairs ij, it's the same thing. That is interesting. Okay, so let's do this. Let's try this. That should keep that from running at all. Ooh. What went wrong? 40. Ah. Yes. Need the correct syntax. Okay, let's play it, see what happens. Okay. Ah, here we go. Okay, so while you can use a hash, it turns out that you cannot use an equivalent hash. See, so what we can do is we can go to prove this, cost so far. Oh. And let's get rid of all this business. So if you look here, we're going to do cost so far of 10.8, and then we're going to immediately check the same thing. And we should get 0. Runtime error, where did we screw up? 36 equals expected near print. Print sum cost. What did I screw up? No, all of those things are right. Oh, we don't need these pairs either. Let's take this out. Try to clean up a little of the code. Maybe there's something else I'm missing. Let's take out this line real quick to see if that... Oh, duh. should be, let's just go 1, 2, 3. See, here we go. So it's nil. So even though this hash is equivalent to this hash, they're not the same because they're different objects created separately. So there's probably like some kind of way that this object is identified under the hood in Lua. That means that just because the items in it are the same doesn't mean that they're actually equivalent. So to fix that, we need to actually have a hash that's based off of the I and the j and not the actual object. So the easiest way for us to do that is to go and create this insert into came from. We are going to, ooh, there's something cool I could do. Yeah, we're gonna make this fancy. We're gonna say insert into we're gonna say insert location into table. And now we're gonna put table, and we're gonna change this to table. Because we're gonna reuse this. So the idea is that we're gonna make two, because I could have just copied and pasted this code, but it's nicer if we actually make this a fancy reusable function. So this insert into came from needs to become insert location into table, and the table is self.camefrom. So it's the same thing, we're just doing self.camefrom. However, since we're going to do it here, and we want cost so far as well, we're going to do cost so far, given the location is start, and the value is 0. There we go. So now we just need to look for anywhere else that we have this insert into came from, which is fortunately only in this one place. So let's paste, oop, that's not what we want. We're gonna put insert into location. Again, this needs to be self.camefrom. And now we just need to look at cost so far. Instead of putting something into cost so far, like that, we want to use this value. So it's going to be self insert into table. The table is cost so far. The value is next neighbor, or the key or location is next neighbor, and the value is new cost. Great. So that does that. Now, however, we can't reference it like this. We have to look at how we reference came from. Why am I not seeing this? Came from. Oh, we were just pushing stuff into came from. I guess we're not using came from anymore. Is that correct? No, we are using came from. Came from. Do we miss that? Frontier. Put next. That's here. No, insert into came from. That's great. Oh yeah, what I wanted is. Oh, that's interesting. We're keeping track of came from, but we're not actually using it. We're only using the cost. That's actually funny. So came from became kind of useless right here because we're actually checking based on the cost. If you remember before, we used to check if it's not in came from. Now, we're actually just checking if it's got a cost and if its new cost is less than the old cost. So that's funny. Anyway, the point is our table has an I and a j, so we have to refer to these things by I and j. And so we're going to make a function to make this easier too and look a little simpler. And we're going to call it get location from table. So we have a table and a location, and we're going to return its value. Alright, if tables I is not in there, then we are going to return, oh, we need a default value. I think our default value actually is going to be nil. So we're going to put nil here. So given a location, if the I doesn't exist, then there's no way that J is going to exist, and we can just return nil. That's not how you spell return. And if the I does exist, we'll return ij, which could just be nil, or it could be the actual value. Okay, so we need to replace these. So get so cost so far of current. Yeah, current should always have a cost so far. It shouldn't exist in our thing without having a cost so far. So this should be fine to say self colon get so far cost so far. And yes, current is the location. There we go. Oh, and I'm gonna get rid of this. That is not something that we're gonna use. Okay, so now we're gonna do, that's gonna get us our location so far, or our cost so far. And this is a bunch of debugging stuff, but let's go ahead and put this in here. Cost so far. Neighbor. Okay, great. Cost so far. And we're gonna have to do it here as well. It's a little tedious, but you know, that is what it is. So if blah 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 equals, yeah, self cost so far, next neighbor equals nil, or that's less than, you know what, since we have this big function, we're gonna do this. We're gonna go neighbor cost so far neighbor, and that way we can just do this neighbor cost so far, that's nil, or if it's nil then we do this, or if it's less than, new cost is less than that, great. Then we're going to insert into the table cost so far, next neighbor, and it's new cost, great. New cost, insert location in the table. Remember, this is probably useless at the moment. And there we go. That should be good. Let's make this a little nicer as well. Okay. Now we're going to check out this one iteration version that we have to make sure it's correct, and then we're going to try doing the real version. Let's get this back. Okay, here we go. Trying to go to 14.9. Oh yeah, so let's make this one. Oh, it's not one. There we go. And let's see what happens. Okay, so we start at 10.8. That's great. These are nil, nil, nil. Here we go. Now 9.8. Hey, this cost so far is 0. Perfect. Okay, so let's put in 10. See if that is correct. Okay, so Oh, I clicked it a couple times. Okay, so we have 10.8, blah, blah, blah. We had all these. Now we go 9.8. It goes through. It should not have included 10.8. So, of course, we're going to do 11.8, which is here. We're going to then do 10.7, which is there. And then we're going to do 10.9, which is there. And then we're going to go to 8.8. That should be the next one. Yep, 8.8. And then 9.7. So here you go. So this, it skipped 10.8 because that isn't, the cost is existent. So it didn't need to add it to the neighbors list. That's great. And now we started building out this thing. Okay, so now we're going to drop in 100. And hopefully, if we pick a place close by, it won't take 100. Haha, there we go. So it didn't take 100, which means it was able to actually path to it, and we're able to get the location. So now we're going to try getting rid of our little safety check here. And so I don't want to look at print neighbors. That's probably fine. Okay, cool. It can go different places. Okay, so now we need to test this by adding a cost to something so that we can see, if you look here, their example, right, is if it's number of steps, like, hey, this is the closest way to get it. But if it's distance, where walking through what are, like, let's say these are trees, takes more, then you can't, then going this way is cheaper. It's quicker than going, like, trudging through all these trees. So what I want to do is I want to take the, well, our orange was like lava. Our blue was our river. Ooh, that's interesting. Nil value. Ooh, where did that happen? Current. Pop value. It was a nil value. That's interesting. Oh, that actually should be fine. Wait, what is it? Oh, attempt to index the nil value. Okay, so sometimes this is going to return nil when we pop it. That means that we're at the end. So let's go look at our priority queue. Priority queue, when you pop it and there's nothing there, it returns nil. What we could do is we could do return property, or yeah, priority nil and value nil. But I actually think it's better. It's better to actually have it. So let's go. We're gonna call this next step. We're gonna give it this guy. And if oh, no, that's not what we want. If, okay, so if next step exists, then current equals next step dot v, else current equals nil. So that way, if we do get it, like, yeah, if we pop it and there is a value, we're going to put that value on current. If there's not a value, meaning if this is nil, so it skips to here, we're going to set current to nil, so that it dies, and we just say that we don't path to there. So we can test that by, we can move around everywhere. That's great. If we try to go to a place that we can't actually stand, it won't let us. Which actually, let's also do this. So we're gonna put a little, oh, I'm really bad at drawing on this. Make a little corner full of dirt where there are trees around it. The other thing I wanted to do while we're editing this map, so we are going to put a bunch of dirt here. We're going to put a river that crosses here. And we're going to put a couple dirt paths here. So this way we can test if like going through the river is more or less expensive than going around the river. Yeah, maybe that'll work. Not really sure. So we'll figure it out. But let's go ahead and save this. I don't know what we were calling it. Test 1 init. The map is automatically loaded. So where do we set that? That's probably in the builder, maybe. No, yeah. Bulb. Here we go. Let's go look at the. Okay, yeah, we're loading init. Okay, so cool. Let's save over init. Okay, let's refresh, make sure. Yep, cool. Okay, so it looks like we got our priority queue working and we got our distance map working. We're just going to test that, and then we're going to continue down our path to getting a star. We have like this next step, I think. Well, we have a star. I think this next step, oh yeah, we have to add a heuristic, and then we get to a star. And I think that heuristic is just okay. That's Dijkstra's. Wait, here we go. Okay, yeah. So this is okay. This is Dijkstra's algorithm, I think. Okay. Anyway, sorry. We're going to get into that in just a second. Let's just verify that this works. So what we have to do is go to our map and change the cost. So we have a get cost, right? And currently the cost of everything is 1. However, we are going to make it a little different. We are going to say if... Oh yeah, so we have current and next. So current is where we're standing, next is where we're going. Let's just make sure we're looking at the cost, right? Where is it? Get neighbors, get costs, right here. So current is wherever we're checking, and then next wherever we're going. What we're gonna do is we're just gonna look at next and see if next is a water tile. So first what we want to do is get a tile. Don't we have a get tile? Place tile, place new grid touch. Oh, you know what? Just, yeah, here we go. If you're using Sublime, the command R will get you a list of all of your methods. So we have load map from here, get enemies, place tile, so we're gonna get start location, get tile size, touch, convert a map location to a display, and vice versa. Get neighbors, get cost, open to player. Interesting. So open to player is sort of like this chunk is getting a tile. So let's go ahead and turn that into a function that we can reuse. And we're gonna just take this whole chunk, we're gonna put it here. So if I is, so this checks if the I is in bounds, this checks if the J is in bounds, and then this is what we get. So let's go like this. And I think we just want the tile info. For now, we're gonna let it be the tile info. If we later want to change it to make it more generic, I don't know what else is on here. Let's just check that out real quick, just to make sure. Oh, it's a forest tile. Yeah, we want to use the whole forest tile. Let's return the whole forest tile. So then what we need to do for our open to player is just say self get tile at location, and we'll go local tile, and then we will go tile dot. Wait, was it tile info or info? I think it was, yeah, tile info. Okay, so sorry, put it another way. So tile info, dot walkable. That's what we care about. Tile info, dot walkable. Bam. There we go. Okay, so we get the tile. So in our get cost, all we want to do is say if self get tile of our next location dot tile info. Oh wait, actually, so let's actually we're gonna go next. That's a better name. Okay, so we're gonna set it to this, and if our next tile is existence. Oh wait, we can just do this, and next tile dot tile info. This will tell us that it has a tile info. We probably don't need that check actually, but that's fine. And is, oh, how do we get its type? So let's go look at, like, it's in builder settings. These are our tiles, I think. So I think this is our tile info. So tile name equals river. That's what we want. And tile name equals river. Let's go with 10. And actually, I prefer to write code like this, where we put cost equals 1. This sets cost equal to 10. Return. Having just one return can make code easier to follow, because then you're like, oh, let me look for if this variable changed and how it changes. If you had returns, you might easily skim over it and not see that there's an early return here. So that should work. Let's go test out our code, see if we're in business or not. Oh, something's wrong. 156. What do we screw up here? Oh man. So we want to look at our previous code. I'm actually going to pull up GitHub so I don't have to. Normally I would Control-Z all the way back. But here's a good opportunity to remind you that all of this source is on GitHub. And you can go get it for free. Just go download it. Okay, so what did I screw up? So our open to player. This function is great. We get this location. We do dot tile info, dot walkable. So what happened? Either our get tile is not returning what we expect it to return, or just make sure there's not two get tiles. No, that looks fine. Okay, so our get tile looks correct. We just pulled out all this code, copied and pasted it. It's the exact code that we were looking for. And we're going to set that to tile. And then we're going to get its tile info. And then we're going to get if it's walkable. Why did that screw up? I don't know. Attempt to index local tile. A Boolean value. How is tile a Boolean value? Oh, because in these cases it returns false. Ah, we want this to return false. Okay, so if we are looking for a tile, yeah, this needs to be, let's do nil. That means we didn't get the tile. It didn't work. There's no tile there. And so now we have to go if tile is not equal to nil, then so we're going to do this again. We're going to open equals false. We're going to return open. If tile is not nil, then what we're going to do is we're going to set open to whatever the value of walkable is. There we go. Cool. Got it. Play. Let's try it out. Oh, what am I doing? Of course, there's more to this than that. We are using get tile here. Get tile. That's our next tile. If it's not nil, okay, that's great. Where do we screw this up? Function value. $135. It's from our get cost. 46, our get path. So 46. We're doing the get cost, which we expect, which has a current and next. And next is a function value. Attempt to index local location. A function value. This is next. What is next? I don't even know what next is. That's not even right. It should be get the cost of next neighbor. There we go. Okay, so now I can move around. Now, if I want to go here. Oh, could not path to location. Can we go here? Oh wait, duh. Of course it can't path that location because it's not walkable. Well, that would verify that walkable still works, so we didn't break that. But let's go make the river walkable. Oh, that's funny. I have lava is walkable too. So why don't we do this? Why don't we make the river cost okay, you know what? Let's do this. We're going to add a value here. Actually, so we're going to put the value on here. So we're going to have walkable not just be true or false. It's going to be the value of how much. So it's going to cost 10 to walk on lava. Walking on lava is really hard. But a river is only 3. So let's save that. So let's go make sure that it doesn't mess with our open to player. Open equals walkable greater than 0. greater than or equal to 0. I wonder if, yeah, because a nil, let's just say greater than 0, because its cost will be 1 at the very least. So this will still return true or false. Here we go. So the cost, let's do this. So next tile and next tile.info and next tile. Actually, then cost equals next tile.tile info dot walkable or interesting. So we want to get a cost, but if it's not walkable, how do we indicate that? Oh yeah, because a neighbor. So what happens is we get neighbors, right? And get neighbors is not going to return things that are not open to the player, which means that they don't have walkable. So here we know that walkable, that it should have a tile info. Like if it doesn't have a tile info or it doesn't have walkable as a number value, then we broke our get neighbors function. Because it's not truly a neighbor. 158. What? Attempt to compare number with Boolean. Walkable is no longer a Boolean. Unless we screwed that up somewhere. So, walkable. Okay, that's great. How are we doing these tiles? Are these, so let's go make sure our bulb forest tile doesn't mess up its own value. No, we don't even reference walkable. It's just on the tile info. Oh, that's right. I just changed build settings, of course, which screws everything up because these values change. What we have to do is just reset this. Go to save as init. Will that save over it? I hope it does. If it does, then this will work. If it doesn't, okay, it doesn't. So here is a clever idea. Let's go look at this. So when we load, so what's currently happening is that our save data for init is bad. Like all these values, like these things are all saved, and we're relying on the values that are saved, not just what tiles they are, right? So right now this map is like permanently saved with like walkable as true and not as a number. So what we should do is we should make this other kind of bigger change right now, which is going to help us out a lot. And that is, we're going to make it so that when we save, we actually only save the IDs of all these tiles. And then when we load, we're going to restore from those IDs. So then we actually are going to cut down dramatically on the actual data that we're saving. So here we go, get save data. So let's go look at, it looks like it's pulling it from the forest tile. Get save data. So instead of tile info, we're just gonna go tile.id, right? And these have an ID, that's great. We could do it by tile name. Yeah, why don't we do tile name, just in case we go and rearrange that order of IDs. Okay, so tile name. So that will do it when we save, get save data. that gets the data, creates the saved data, we go and save. Now, here we go, load map from data. Now, what we're gonna do is from here, we're just gonna get an ID. So what we wanna do instead is go, ooh, this is in the map. I think this is fine. We can still do this here. Although I forgot what the name of it is. So we're gonna have to get from builder settings, which is over here somewhere. Bulb builder settings. We're gonna have to get these types, which we have get type by name. So that's what we're about to do, but I need to make sure I use the same object. So it's gonna be like this. It's gonna be get type by name. And this is the name that we saved. Okay, so here's the funny thing though. Let's not save this. So it's saved here. So now what's happened is we just loaded from one thing, and we are now going to save it as that different value. Let's go ahead and save that. Let's load test 1. Save test 1, load test 2, save test 2. So what I'm doing is I'm loading them in the old way. Oh yeah, clear just has nothing in it. And then I'm saving in the new way. And what this means is that I've just converted over our code. Now, when I try to, now that I've saved over all these, now watch, if I try to load, let's go test 1, it should fail. It's failed because, okay, stop. Because the values have all changed. I've saved it in this new way where our save data is just, as I pointed out on the tile, our save data is just the tile name. So what we need is to restore it from the tile name. So what we're going to do is we're going to do get item by name, given this name, but we need to figure out what that is. So usually in our main file, yeah, here we go, bulb build settings, okay. Pretty straightforward, but it's sometimes good to check to make sure that I'm doing the right thing. Okay, so get by name. Now if we save it, hey look, it did it. So now we can load test 1, we can load test 2, we can load cleared, we can load test 3, and we can load init. Great. Now we can go play it, and everything's broken. 26. Oh, that's because something is wrong. 26. That is because when we go to play, we're actually on our builder map, I believe. Or, I mean, not our builder map, but our regular map. So what did we call that? Did we call it forest map? Bulb forest tile, great. It just creates one. Load map from data. Okay, yeah, so this load map from data needs to match our builder load map from data that we just changed. Okay, so we need to get this piece. And let's just make sure we change it. That's all that's changing. Still the exact same. Cool. Oh, do not need. Oh, there we go. Change the tab. Okay, so there's that, and what is this doing? Ah, okay, so if tile name, well, we don't need to do that because it's just player. Okay, so what we're gonna do is we actually have to do this. New tile, equals this guy. Wait, nope, this guy. Gonna load our new tile. Let me just copy this line. And then we're gonna reverse everything that I just did. Okay, so what we want is to go here, we're gonna look at its name, get the tile by name, so we're gonna restore it to a tile. See that as new tile, and then we are going to say new tile.tile name. And the reason I did this is because even though tile name is actually what was in that original value, right here we actually need to know a value that's on the tile. And then to be consistent, we can just go new tile here. Oh, and this is gonna need this as well. Oh, that's fascinating. Why is it? This says tile info, but it's not actually the tile info. Is it? Get tile by name. No, I guess that is a tile info, but then, oh yeah, it's tile info, not tile name. Okay, cool. Save it. Something else is wrong. 159. Wait, 159? Where's that? 159. Attempt to compare number with nil. Okay. What's sad is you can't say like, hey, is nil greater than 0? Well, nil's not a number, so it's no, it's not greater than 0. Unfortunately, no, we have to check to make sure it exists, which is fine. This does the exact same thing. So play, okay, everything's moving, the player's moving. Okay, so if I click here, see, it's cheaper to go around this way than it is to go around this way. If we go here, okay, that's cheaper. Okay, here we go. Let's try to set up a good example. Oh, you know what? I have a good idea that will make this maybe interesting. So let's go look at our tiles. Or let's go look at this. Okay, so let's A-star algorithm, blah, blah, blah. We've got a tile. I have an idea. We're just gonna set up the exact example that's over here. This will make it easier to test. Let's load. Oh yeah, we don't have to load clear. We can just hit clear. Nice. Okay. Wait. Let me make sure that this is right. And when I click that clear, that we haven't changed something that breaks everything. Okay. Cool. Okay. So let's do this. Let's put a wall here. 1, 2, 3, 4, 5, 6. And let's go put some lava. And 1, 2, 3, 4, 5, 6, 7, 8. Ooh. There we go. And there we go. Oh wait, was that 1, 2, 3? I don't know, that should be 2. Maybe I went a little further than I was supposed to. That's okay. Yeah, I did. I added an extra tile, but whatever. And then let's go get the player. The player over here. Oh, cool. So now I want to take this and say, actually, you know what? I can just go fix this real easy. Boop, 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 boop. There we go. exact same thing. Oh wait, and the player should be right here. Cool. So now we can compare. Let's call this a star. Now this list is going to get too long and it's going to look bad, but that's okay. A star. Great. Okay, and then let's do a river version. Cool. Oh, A star. Okay. Now let's go play it. So if we click right here, see, it's cheaper to go around. But if we click right here, nope, still cheaper to go around. Oh yeah, because it's like 10. Okay, so let's see if we move. He has this nice thing. Okay, let's click there. Put our player back where our player was. 1, 2, 3. Okay, let's go right here. See, it's cheaper to go around. Now ours goes around the bottom, which should be fine. It just has to do with like some slight differences in how our algorithm checks. What I want to do is figure out, okay, number of steps. So if we go here, okay, so that's a problem. Oh wait, I don't know what his distance is. These are, this is 6, 11, okay, his are 5. So let's go set ours to 5. Actually, I'm going to leave lava as 10. I'm going to set the river to 5. And of course, now we don't have to do anything fancy. We can just reload the map, and it will load up with our 5 value instead of our 3 value, which is nice. Okay, so let's play it. Yeah, it goes around. Click there. Click here. There you go. See? So if we move here, it's quicker to go through the water. If we click here, oh, yeah, if we click here, we got to go around because it's cheaper than going in through the water. Interesting. See, there you go. Yeah, if you're going here to here, it's great. If you're going one more tile out, it's cheaper to go around. Cool. I'm trying to think of how many tiles you'd have to go through, how far away you'd have to be from lava in order for it to be cheaper to walk through the lava. So let's do this. So the number of tiles would have to be like 10. I think if we did something like this, might be able to find a place where it's cheaper to go through than it is to go around. See, there you go. Even one away, it's like, you might as well go around. Awesome. Okay, cool. So we've got distance in there. That's excellent. It's, everything is saved. Okay, so we want to move on to the next step. So we've added movements costs. Okay, so now we want Dijkstra's algorithm. Wait, that is what we just did. Dijkstra's algorithm. Hopefully I'm pronouncing that correctly. We'll add a path, blah, blah, blah. Okay, using a priority queue, it's a regular queue, changes the way the frontier expands. Yeah, that's great. This is why I recommend the site. He does these really cool animations that show you how things expand, and like, look, it's easier to go here directly, etc., etc. Let's see this cool animation of how you would get to all the different steps. Here's the frontier expanding and the way in which it expands. Anyway, you can use more interesting graphs. And so you have distance from room to room. So this is something that, like, if you're doing, he gets into this in some of the other examples, but probably on this implementation notes page. But like, if you're trying to do room to room stuff, you don't necessarily need to have a grid like this or break it up. You can actually, like in this case, he's just moving from the center of one room to the center of another room. That's a good way to just path through arbitrarily complex worlds. Okay, so anyway, Breathford's the frontier expands. So we're trying to find a path on all locations. Okay, so here we go. So one of the things we talked a little bit about last week, I think. It's this is great if you're trying to find a path to all locations or to many locations, right? Because what we're currently doing is the equivalent of this, where we're like, hey, let's go find all of them. And we're actually doing just a little bit like early out, which is once we get this line, we stop. But look at all that space that we've done that we didn't really need to do. But see, what you want is for it to expand towards the goal rather than other places. So you define a heuristic that tells us if we're closer to the goal. So on just a very basic square grid, if the absolute value of a location is better, then it means that you're probably getting closer. So instead, in greedy best first search, we search the estimated distance to the goal, and that's how we change the priority queue to basically be set up to use that. So location closest to the goal we explored first uses a priority queue from Breathford search, but not cost so far. Oh, dang it. Now we're going to lose cost so far. And we're going to go back to... Oh, yeah. Yeah, we're going back to came from. So what I actually wonder, do we save... This is A star. Oh yeah, we called it breath first search, right? Yes. This is our first version, our very naive, simple version. Great. So this was our super simple version with our early out. Now what we're going to do is we're going to save this as our it's not technically A star yet. Call this Dijkstra's Dijkstra search to keep it similar. Is that the name? Did I spell that correctly? Dijkstra. Okay, so we're going to save that because we want to keep our older versions around. It's helpful for learning purposes. And now we're going to continue to redefine it to make it better. We're going to add this heuristic to get a greedy best first search. And then A star, it works well to find the shortest paths, but it wastes... Oh yeah, so Dijkstra's finds the shortest path, but it wastes time exploring directions that aren't promising. Greedy best first search explores in promising directions, but it may not find the shortest path. The A star algorithm uses both the actual distance from the start and the estimated distance to the goal, and the result is that you get there sooner. So this is actually uses the cost so far plus the heuristic. So we want to get to this, but we're going to go start by just doing this version. That actually might be easier to build off of our old code. If we look at our breadth first search, is this similar? Let's see. Oh wait, we still need a priority queue. Never mind. This still needs a priority queue, so it's gonna have to be off of this one. Okay, so I'm gonna go like this and start by saving this as our other version. We're gonna call it greedy best first search. We're just gonna be very descriptive here. We're gonna go ahead and save that guy. Blah, blah, blah. I am going to be splitting this stream into two. So actually, this is probably a good time to stop. I'm gonna take a quick break and then come back and do the last half, which will be getting us to our A-star algorithm. This greedy best first is gonna should be simple since we don't have to make a priority queue. And then the secondary part where we do the A-star should also be pretty simple on top of this. Okay, so we're going to take a break. This is going to end 13. I'm actually going to check in all this code, and you can get it again at github.com/TylerMakes/Bulbasaur. If you can just remember, actually, if you can just remember TylerMakes.com. Well, no, that's not right. I don't have a link to the GitHub there. Anyway, github.com/TylerMakes. I'm going to put this in the video notes. I try to do that always so that you can find it. Go check out the code, use it, have fun, make cool stuff. Let me know what you've made. And then what I'm going to do is, make another video. All right, so see you in a couple minutes.